Okay. Have you pulled it up yet?
The quiz?
Mm-hmm.
I did.
Okay, perfect.
It's really hot in my room.
My room at night's been getting really hot. I have to have the fan on.
I live with old people, and for some reason, they get cold.
I know.
Suffer.
Mm-hmm.
And they have on the heater, and I'm really hot because I'm used to Rexburg weather. I'm not used to it being, 70 degrees.
Mm-hmm.
So
It just barely
I'm
started to
like,
get cold here.
see, not fair. That's the weather I'm used to, the cold.
Yeah, I walked to class yesterday, and as soon as I got in the building, I had tears because the wind was so cold.
Oh my goodness, that's funny. I hear like, it's crazy out there.
Yeah.
Glad I left when I did. Although I think I might be moving to Utah.
Oh, cool.
Who knows? I might be in the cold too, but
Mm-hmm.
that'll probably be like later this year. I have yet to decide.
Right, that's cool.
My friends are trying to convince me not to move, and I told them to get out of my face. So I have SPSS up.
Okay, so for the first question, it says in an ANOVA hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others. I think it's true.
That's true. Oh, see, great minds think alike.
And let's see. Okay, 4. Let's see. Requirements.
So it's going to be variances are equal in each group.
Mm-hmm. And then the data in each group are normally distributed.
Yeah.
Okay.
I think they do have to be positive though. I don't remember.
I don't remember reading that.
Here, I'll look really quickly.
Okay.
Yeah, it doesn't have to be positive. It
Okay. 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 To check if each group is normally distributed, do the following: a QQ plot. You just follow it on the little line thing.
Mm-hmm.
Okay. 6. We assume the variance in each group is the same if the following happens. Does it say something about the largest variance is less than 4 times the smallest variance?
It says the rule we will use if the largest variance is less than or equal to 4 times the smallest. Oh, you were reading that.
Okay.
Then we will conclude that all the variances are equal. So,
okay.
The one we need to do is the largest variance is less than 4 times the smallest variance, isn't it?
Yep. Okay. Heck. 7. An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, right? So a 1, 2, 1, 2,
1 to 2, 1 to 3, 2 to 3.
How many?
Oh, let's see what it wants us to do. I think it's going to be like 5.
1, 2, 3, 4, 1, 8.
Actually, it might be more than 5. It might be 3. I mean, it might be 6.
Okay, so 2, 4, 6. I think it's 6 because if it's 2 sample t-tests between every pair, and there's 4, would we go 2 times 4? Or no, that's 8. Let me write it out.
That's what I'm doing. 2 to 3, 2 to 4. 1, 2, 3, 4, 5. Oh, I was right. It is going to be 5.
Okay.
Because you do 1 to 2, 1 to 3, then you do 1 to 4, right? Since we're extending it to 4 samples. Then you do 2 to 3 and then 2 to 4. Maybe I did this wrong. I think I did this wrong.
So when there's 3 pairs, it would be 6, right? Because
No,
from 1 to
if
2,
it
you
says
do 2.
no, it says how many pairs would we have.
Mm-hmm.
So if there are 3 samples, there are 3 pairs because it goes 1 to 2, 1 to 3, then it goes 2 to 3 because we stop at 3, right?
Uh-huh.
Now, if we do 4 samples and we conduct it how they did it here, except for we go 1 to 2,
Uh-huh.
1 to 3,
Mhm.
and then we go 1 to 4,
Mhm.
right? Because there are 4 samples.
Okay.
Then we do 2 to 3,
Okay.
and then we do 2 to 4, right? Or maybe we would do
Would we
3
do
to 4, and then we'd go. Ooh, I don't know. Never mind. Don't ask me. It might be 8.
So that's 1, 2, 3, 2 to 3. 1 to 2. So it looks like it goes 1 to 2, 1 to 3. Then would it go 2 to 3, 2 to 4? And then would it go 3 to 4? And then 4 to 4? No, I don't know. You think it's 5?
Mm-hmm.
Okay. You put 5, I'll put 6.
Okay. And we'll see who's right.
Mm-hmm. Okay, so let me get up the soccer shoes data.
I am.
I feel like I'm going to have a hard time with this because it says variance. And I'm never good with the variance.
All we have to do is just click on ANOVA, right?
I hope. I hope. It's been a while since I've done this.
Let's see. The good thing about this stats wiki, it tells you how to work the SPSS.
Oh, good.
So, from what I see, okay, if it's not numeric, and one of them doesn't look, and one of them isn't numeric, which is footwear, we have to do the automatic recode.
Right.
So we do the automatic recode on footwear, and I'm just going to name it group code.
Okay.
That's what I name everything else, and that's what they name it in the book. So that's what I'm going to name it. And then once we did that, we can now move on to analyze descriptive, compare means, one-way ANOVA.
Okay.
And then
I don't know why it won't ever pull up this stupid data.
So once we put the kicking accuracy in the dependent list, and then the factor is the group code, and then we click on options, and then we click descriptive, right? And we also want to include a means plot.
Okay, hold on. Because my SPSS is not going to pull up.
Are you good?
Like, it opens SPSS, but it won't open the stupid data set.
I think I did this wrong.
Come on, open up. Oh, I did not do good on the last homework quiz.
Oh yeah, neither did I. But then again, there was a screaming baby in my ear, so kind of sucked. I hate it when family brings over stupid kids and then I have to hear them scream. As you can tell, I'm not the biggest fan of children.
Right.
Analyze descriptive Statistics.
Come on, open up.
Normality plots with
Okay, let me pull up the wiki.
Holy Mama Jamma. This is a lot of stuff. If I did this
A
correctly.
lot of steps.
Yeah, this is a lot of stuff.
So where at in the book does it say? Is it analyze a variance?
Mm-hmm.
Okay. My word. Come on, SPSS. Don't fail me tonight.
SPSS, don't fail me now. Sounds like what was happening to me. Stupid.
Okay, to conduct a test.
Tell me when you get everything working.
Okay. I don't know how long it's gonna be.
Hope you don't have any plans tonight.
Nope. I have a bunch of reading. Oh! And I have to come up with a schedule for next semester because I register tomorrow morning.
What classes haven't you taken?
I need to take anatomy again.
Take it online.
Online?
Yes.
Okay.
Let me tell you why. Because online is better. Because if you take it in class,
Mm-hmm.
you have to pick. You have all these teachers to choose from,
Mm-hmm.
and not all of them teach the same thing.
Right.
The test is the same,
Uh-huh.
no matter who teaches it, and they suck at teaching.
Okay.
And so, to either take it online or get Brother Hunt.
Hunt?
If you haven't
Okay.
taken it from Brother Hunt, because Brother Hunt is the department head and he writes
Mm-hmm.
the test, so he'll actually teach you what's supposed to be on the test.
Okay.
If you take it online, don't take it from Wright. She has like this really, really foreign name.
Okay.
Stay away from her.
Okay.
So what else do you need to take?
I'll have to look, but I think that and
Have you taken
maybe
HS 390?
I'm in there right now. I may have to retake that. We'll see. I might have to drop it.
I love Brother Hopla. He's so funny.
Okay, it finally pulled it up. Hooray.
Have you you haven't taken HS 391 yet.
Oh, I'm taking that right now.
Oh, online or in class?
In class.
Oh, ew. How do you like Brother Benedict?
It's okay.
Yeah, I
Kind of
know.
odd. But I have a way good group. My group is killer. We get everything done.
Oh, that's good. What are you guys doing?
We're doing research about mobile phone help apps.
Ooh, that is awesome. I had to do radon testing.
Oh, not fun.
Well, actually, mine was easy.
Oh,
Except
okay.
I had a lot of research I had to like funnel through.
Mm-hmm.
And so now, then the next semester, so spring semester, he got other students to do it and then got funding for the stuff that me and my group researched for them.
Okay, good.
But they get all the credit.
Mm-hmm. Yeah, of course.
I just want to stab people in the eye when they do that.
Okay, so I go to transform. Compute variable.
No.
Oh, okay.
Go to... No, remember you got to do the automatic recode.
Okay. I go to transform.
Yes.
So do I recode into same variables or recode into different variables? Oh, automatic right here.
Yeah.
Losing my
You do
mind.
automatic recode and you put the footwear,
Mhm.
rename that. Because comments are not really, isn't anything you want to turn numeric.
So I move footwear over to the variable.
Yes, and you rename it.
I'm just gonna name it group. What? One.
Say feet.
Feet. Okay.
Yes. I've been teaching myself how to write in cursive. So everything I write it in cursive now. And it looks ugly.
Okay. Got that. So then I go to analyze, compare means,
Mm-hmm.
one-way ANOVA.
Yes.
I
Make
move,
sure.
I move the feet.
Huh?
Where do I move the feet to?
The footwear that you just named it,
Uh-huh.
a different name, that's the factor.
Okay.
The kicking is the dependent list.
Okay. So our options, let me look. Descriptive, fixed or random effect.
No, you just want descriptive and then a means plot.
Okay. What's contrast? Nothing.
Contrast? What are you looking at? Oh, you don't need to worry about all that stuff.
Okay.
And then what you're gonna do is you're gonna get all this stuff. Then you about to go to analyze descriptive stats, explore, and then you're gonna move the variable containing your dependent list, which is your footwear. I mean the kicking. Yeah. Kicking.
Okay.
And then the factor is the one you renamed.
Okay.
And then you click on plots, and then mark the box that says next to normality plots with test. Then click continue, then okay, and then all.
Do we need a histogram?
No.
Okay.
And then all these graphs will be created, and you're gonna be like, "Whoa, dude, why are you showing me this?" I'm telling you, it's dumb.
Okay, so I got the descriptive, ANOVA, means plot. Okay.
Now, how to read all this? Don't know.
Right.
I forgot which ones we're supposed to read.
Oh my heck.
I know.
So I know, so before this, does it say variant?
I'm gonna punch this thing. It's like
Descriptive, blah, 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 blah. Mean.
Shut up. Sorry, not you. We're supposed to have a chart that says descriptive and then ANOVA. Either we did something wrong, or
Mine's still processing all of the things that it has to pull up.
oh snap!
I didn't know there were like 1,000 things that it was going to pull up.
Yeah.
So we're supposed to have a, what is it called, ANOVA?
Yeah, but see, I think I did something wrong.
So I have a one-way descriptive. Okay, so I have one that says ANOVA.
Maybe you do have one that says ANOVA, because I don't.
Yeah. So scroll up to the top.
Oh, okay, never mind. I have it. I lied.
So, like for the degrees of freedom between groups, did you get 5?
I did.
Okay.
All right, is that the one we're supposed to use?
Nope, I don't know what I don't know which one's supposed to be called for the variance.
He's like, I don't know.
Sum of squares, maybe? I'm not sure.
I'm like reading this and the F statistic.
Currency.
Oh, my mom is screaming at the dog.
Because let me Google how to get variance. So it says work out the mean, so the simple average of the numbers. Then for each number, subtract the mean and square the results. Then work out the average of those squared differences. What the heck? Let me go to a wiki. Let me go to a variance calculator. So I guess variance is ANOVA? Is that what that's what the book's saying?
Yeah, we're supposed to run an ANOVA test.
The variances are equal for each group. Variances.
It's 5:30.
You want to try moving to the next question? While we eventually figure this out.
So it says you can find the variances for each group by looking at the same output that generated the QQ plot. Look for the descriptive table.
We have our descriptive table.
Come on.
What will we put? The minimum is 22 and the maximum is 48? Because that seems like... No, the minimum would be 19 because that's the smallest one.
So yeah, we'll put the one that's the smallest and the one that's the largest.
So
I'm trying to scroll up to the descriptive. Yeah.
But how do we know we did this?
Stop. Okay, so for A, Variance, okay, so 27.358 B is 29.484. C is 7. D is
So I think that it is.
How many categories are there? E is
Wait, which one are you answering?
31.011. I'm trying to answer what is the minimum for the group 6 groups, and what is the largest for the 6 groups.
You just can't take it from the little chart right here?
And then the socks. That one is 40 points. So in the descriptives, it says variance, and it says variance for each group. It's kind of towards the top.
Uh-huh.
Okay, so the smallest one is... So the smallest one is 27.208.
Wait, how are you getting this?
I think I did it right. I don't know. So have you found descriptives?
Yeah.
So on there, on the list under mean should be variance.
Descriptive. I don't see variance. Did I not check something and you did?
I don't know. It's not right. What's under your mean?
I just have n, mean, standard deviation, error, lower bound, upper bound, minimum, and maximum.
Okay, what did you get? What do you think the lower is? Oh.
To be honest, I really don't know.
That's a confidence interval. Because I can share my screen and I'll show you where it says the variance. Okay, so see here on mine, it has like this.
You're talking about that one.
This, yeah, the A, B, C.
Okay, I'm there.
Okay.
So I see the variance.
Mm-hmm.
Oh, you're looking at what is the smallest between all of them.
Yeah.
Okay, that makes sense. So the highest one would be 53?
Yep.
53.158?
Yep. Oh, stop scrolling.
My mother's calling me. Mom, this had better be good. What? Oh, okay, well, I'll come get them when I'm done.
Okay. I hope that looks like it's right?
I think so.
Okay.
But it said like the minimum and maximum. I didn't know it was talking about. Oh no, it was talking about the variance. Never mind.
Okay.
The test for equal variances is satisfied for this data. How do we check that?
Test for equal variances is satisfied. I think it's satisfied. Because we did it all. I don't know.
When we do it, if it's wrong, we can only get it right the next time. So.
Right. Okay, so 11. Let's see.
I put that.
True?
It wasn't normal from the QQ plots. Scroll down to your QQ plots, and I'll like show you what I'm talking about.
Okay, and then I'll. Okay. Oh.
Okay.
Stop.
So you see how it has the line going straight through? Usually data falls on that line. There are some that have straight lines away from the straight lines. There are some that, see, this one we could consider normal. It has minimal outliers.
Okay.
The next one, however, you see how it's like just, that's not normal data.
Right.
If I remember correctly, you know?
But C is.
Yeah, like, if you look at C, it's like, that it's sort of normal.
D is pretty normal. E
but
is.
I think it's asking for all 6 of them. Yeah, it says each of the samples are approximately normal based on what you see in the QQ plot. I don't know if it is.
I would say it is because only a couple of them aren't normal. Okay.
Well,
perform an ANOVA test and observe that the p-value is...
11?
Huh? I'm going to say true for 11.
Okay. Let's perform an ANOVA test.
Yes, I'm going to stop sharing my screen. Okay. So, so I do the same thing, but how do you get rid of SOX data?
But hold on. How are we... That's not our p-value.
How do we figure out the p-value for all of them? Oh, let me scroll up to this table on the top.
Because here our p-value is the F distribution, right?
I think it's still sig, because on my sig under the ANOVA it says 0.081.
Oh, never mind then. So what we're gonna have to do is we're gonna have to go into the data to where it says footwear, click on it, and delete socks.
So I go to the data.
And just press delete on socks.
Which is socks?
The one all the way at the bottom that says socks.
No, like I mean like on the data set, don't we delete it? And then run the test again?
Actually click on the data set and delete
it. Would it be A, the footwear?
No, it literally says socks. Go all the way to the bottom. It says socks.
Oh, okay. I see it.
Because I'm deleting it now.
Okay.
I mean, I think there's actually a way we can get rid of them, but I don't remember how. I'm just going to delete it. And if the p-value is the same, then we know we did something wrong. And then I have to re-download this. No big deal. DVD.
Okay, got rid of socks.
How did you do it so fast? I have to literally delete each one.
I highlighted them all the way down and then highlighted them all the way across. Then I right click and then just click cut.
So then we're going to run another ANOVA test using this?
Yep. Analyze.
Oh wait, I think we have to rename the group code. I think we have to do another automatic recode.
Okay. So what about the feet one? Would we have to get rid of that?
No, actually, let's just run the test over.
Okay. Automatic recode. Transform automatic, right?
Oh, the significance is different. It's 0.309. It gets bigger. Like the p-value gets bigger.
So we don't do an automatic recode again, we just do the ANOVA?
Yeah.
Okay.
How are we supposed to know if the p-value is to the right or left of the f statistic?
Okay, what does it ask for the p-value? Did you get 0.309?
Yes.
Okay. Okay, the test statistic for an ANOVA hypothesis. Let's just say right. Let's just say right, and if it's wrong, then we know what's left.
Okay. Now we have to pull up the other.
Okay, I'll close this data out. I don't want to save it. No.
I feel like these questions are never ending. Oh gosh.
Yeah, this is gonna be.
This is long. It sucks.
Yes. Cancel that. I don't think I downloaded it, did I? Hot dogs, here we go. Okay, so we just run the ANOVA, or do we just run a QQ plot?
Run the QQ plot.
So I just go to what? Descriptive.
And then go to explore, I think.
Or can I just go to QQ plot? QQ plots?
We can, but I think if we do it like that, it's only going to run it for one.
Okay.
Or, I mean...
I'll just go through Explore. Okay, so let's see. Would the type be the dependent, or would type be the factor?
I think we stick to calories and sodium. What is it asking us?
Okay. Let's examine the first. Let's examine calories first. Okay. So just for calories, dependent, right?
Mm-hmm.
Okay. And then let me click on plots.
Would factor be... We do have to do an automatic recode. Because we need to change type.
Okay.
Because that's what we're comparing it against.
Okay. Cancel, cancel, cancel. So we got to go to automatic recode.
Mm-hmm. Then go to descriptive stats, explore. And then we're going to...
Okay, so after...
the calories first or the sodium?
It says calories.
Okay, and then we go by the factor list is the meat.
So I'm in the automatic recode. I just change calories.
Mm-hmm.
Okay, to a new name.
Mm-hmm.
Cal.
No, you change not calories.
Okay.
You change type
Okay.
to a new one. Because it has to give it a numerical factor of 1, 2, or 3. Because
Okay.
you have to think about it. If we're comparing calories, we're not comparing calories to the sodium level. We're comparing the calories between the meats.
Okay. Can I just say meats?
Yeah, sure.
Do you have the 7?
Huh?
Do you have the iPhone 7?
Yes, I do. It has the 2 cameras.
So, did you have trouble like losing service?
Yes, actually, this phone kind of sucks.
Like I never have service. It sucks.
Which color did you get?
Jet. I got jet black.
How did I know?
Yep.
Full glossy.
Yep. I had to wait. I just got it like 2 weeks ago. I had to wait forever.
I pre-ordered mine and it took me a month to get it.
Mm-hmm.
Yeah, I got rose gold. Did you get the plus or just the regular?
Just the regular. The plus wouldn't really fit in my pocket, so.
The plus doesn't fit in my pocket either, but I wanted the second camera.
Right. Yeah, my mom got the plus, but I didn't want it. Okay, so now we'll go to One-Way ANOVA.
Yeah, and then I clicked. Oh wait, did you run the ANOVA test?
I'm going to.
QQ plots.
We need to do the QQ. Well, I'm just gonna first. I'm getting all kinds of lost. First, I need to go to Explore.
Yeah. Let's run the QQ plot first, then the ANOVA.
Mm-hmm. So the dependent list is the new one?
The dependent list is the calories.
Okay.
Remember?
Mm-hmm.
And then the factor list is the glucose.
Okay.
The meats. Like that commercial. We are the meats. I think it's Arby's.
Mm-hmm.
And then remember you click on plots and you click normality plots with tests.
Okay, I'm gonna have to do it again. Because I forgot to click that.
Oh dear, Cody.
Explore, so plots, normality plots test. Continue. Continue.
Uh-oh. I think you might have been right, Cody.
What?
Oh no, never mind. It gave us all of them already. So now we're supposed to compare the variances to the QQ plots. I don't know what that means.
Okay. Let me write, I guess we don't write the variant. We just look at the QQ plots?
No, it says, let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
Okay, let me come up here to variances. Stop. Okay.
They have been met.
They have been met. The first one.
No, I just say I think that they have been met.
Okay.
But, oh yeah, the first one.
Okay. Okay, so now it says run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find the degrees of freedom are 2 and 51, that F equals 16.074, and the p-value is 0. With a level of significance 0.05, what conclusion can you draw from this? Well, since it's...
You click descriptives and means plot when you run the ANOVA. Okay.
So it's basically, it basically did the test again, basically did the test for us. So we just have to determine that we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
We have sufficient evidence.
Because the level of significance, right?
It's within the level of significance. But now we just have to see if all 3 hot dogs have the same mean number of calories or that there's a different mean number of calories. I didn't even know what the null and alternative hypothesis was.
Me either. I think it's just, it basically did the test for us, and we just had to be like, okay, so we have degrees of freedom that are 2 and 51. The F is this. P-value is super low. It's 0. So,
well, no, we do have sufficient evidence, but which one is it? Is it that they have the same number of calories or that they have a different number of calories?
I think that they have a different number of calories. Let me scroll up and see if I can see if there's like
well, to see, it says run an ANOVA test to determine if the mean number of calories is the same for all 3 types. If we reject the null hypothesis, that means we proved the null to be sufficient, right? We proved, HO. So then that would mean that we have sufficient evidence to claim that all 3 hot dog types have the same mean number of calories.
Okay.
Then the latter, which would be the alternative hypothesis, would be that one of them is not equal to each other.
Okay.
So then that would mean that there was a difference in the mean calories. So I think it's the first one. Look at me talking all statistical.
Okay. So 16. Now let's examine. Oh my word, this quiz is so long. Now let's examine the sodium levels. Construct QQ plots of the sodium level for each of the 3 types of hot dogs.
Calories and stick sodium in there.
Yeah.
Oh my goodness. I feel like I'm going to grow old and die looking at all these.
I'm going to click C.
The assumptions have not been met. It is safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal. Okay. That makes me want to change 14.
Okay.
Now we have to rerun the ANOVA. Where the salt? Yay. This better be right, because I literally don't have the patience to redo this quiz.
So it says despite the possible, so we have to do a QQ plot for poultry. It decides blah 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 blah. What is this p-value?
QQ plot for poultry. Just go look at it. Meat, sodium, and bait.
Okay, so I need to do. Do I have to do another automatic recode?
No.
Okay, perfect.
So which one are you trying to answer? Because the p-value is 1.17. 17?
Yeah.
Where are you getting that from?
No, I'm on question 17.
Oh, I'm like, dude, I don't even see that. Oh yeah, so I got 1.79. What did you get?
Let me hurry and do the descriptive real quick. So, meats is not my factor list. Or it is. Yeah, it is. I need to move sodium and take calories out.
Just move sodium and calories.
Okay.
I hope this is right. Jesus, please let this be correct. We have insufficient evidence.
Okay.
So if you get 1.79, we have to fail to reject the null hypothesis.
Where are you seeing like the answers or like the p-values?
Don't we look on the little box that says ANOVA? And look at the significance? Isn't the significance the p-value?
Oh, I should have ran an ANOVA. Okay.
Yeah,
Let me go back because I just did descriptive.
I know you're good.
Stop. So dependent is sodium. Meets its factor. Do I need to click on options? Descriptive, means plots.
Yeah.
Okay, you got 0.179?
Yeah.
Okay. That is what I got.
So we have insufficient evidence, my friend.
Okay.
And I think yours is B, just like mine.
Did you say the last one's B? We do not have sufficient evidence?
Yeah. Because you see how high that p-value is?
Yeah, that's high. So, okay. Do you or I want to submit it first?
I'll submit it first.
Okay.
Submit it first.
Okay.
I'm nervous. Don't you submit quiz. I should be getting a text message telling me whether or not we got an F. So far, uh-oh. So we got 7 wrong.
So
Well, I got 7 wrong, so you might have gotten 7 right. 15 is wrong, so 7, 15, and that's it.
oh,
So
good.
let's see how we can change 15. And then I'll have you submit yours to see if you got 7 right. So 15 would be, well then you know what? I was wrong, because change it to we have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories, and see if that's correct.
Change 15 to what?
Change it to we have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories. And then submit yours and see.
Okay. So 15 and then you said 7?
Yeah, 7, we had a different answer, right? Remember, you put 6 and I put 5.
Mm-hmm.
So submit yours and see if 6 is correct.
Okay.
It's 6 o'clock.
Okay.
100.
Okay, so it is 6.
Hooray, we did it right.
I know, I'm so excited. Do you know how stressed out I was in the making of this quiz?
Oh my word, this was a stressful quiz.
It really was, but you know what? This is practice
Yeah.
for when we legitimately have to do this on the test.
I know, I'm scared.
I know. I'm like, ugh. So
Okay.
what are we going to do about 15?
Okay, so I'll tell you what I put for 15.
No, I mean 15 as in quiz 15. Because it's due on the 4th. Our last day for our test is on the 5th.
Oh my word. Crap.
So I know you would rather be studying because you have a lot of other tests
Yeah.
to do.
Yeah.
Do you want to do 15 tonight, or do you want to meet again sometime this week? See if the others can meet. Malia may not be able to meet,
Mm-hmm.
but we should at least give Gabriel the option to meet
Yeah.
and 15 with us.
Yeah,
So
I
do you
think we
want to do
should
tomorrow or
do
Thursday?
15 on Thursday. Is that the 4th? Okay.
The Thursday is the 3rd.
Okay.
Okay. Are you sure you will be able to make it on Thursday?
Yes. Yes.
Because I know we all make plans and we all have lives and et cetera, et cetera, et cetera.
Yep.
So that's why I want to make sure you can meet. And I don't want to, and we don't want this to infringe on anyone's plans.
Right. Yeah, I'm okay because I'm leaving Sunday for Utah. So
Okay.
so let me stop recording. Just a
Okay.
second.